Hi, welcome back to my channel. Today we are going to talk about IT basics. So whenever whoever is joining into the IT industry, what tool sets, what languages essentially required, how they can develop their career into the IT. So that's all about we are going to talk about. Let's jump into the understanding of the basics. So information technology basics. So new to the IT environment, there are certain newcomers who freshly graduated out from the college who is entering into the IT industry, and there are people from IT industry who already have experience, but little experience. They also can try to understand and focus career oriented things in the IT industry. So here I'm primarily focusing on certain bullets. So which is talking about languages to learn and adapt. What languages usually the developers require to learn and gain their better ways in terms of the development. And also we can understand the software development lifecycle model, how basically software development model works, and then we can understand the entire process from the IT environment. And also it is essentially to understand the hardware because we are all using today the devices. The device could be a phone or laptop or a desktop. How this hardware fundamental works in the real environment when we work in the IT industry, and how to become a strong handheld writing the code. I mean to say, see, you know that you can write a code, but still you wanted to learn something new, which is completely unaware by you. But how do you adapt those things? And also, we can learn what are the IT terminologies which is being essentially used in the industry. Okay, so it was not like olden days. Today, the environment is very much dynamic. That means every 6 months to 1 year, there are a lot of new languages coming up, or new scripting technologies are coming up, or existing technologies being upgrading. This is so much dynamics. That means there is no restrictions because the open source era is being adapting rapidly than the proprietary tools. In the olden days, people follow the proprietary tools and they have a limited usage based on the product documentation. But in today's era, no, not like that. There are a lot of tools coming up and people are adopting and working on those tools or frameworks and achieving their project goals. Okay, so here, also people, everybody works for the money. So which language is better to adapt, and how much they can get the salary wise. Okay, so those are all additional factors which will enable every individual, right? So we know that high level languages in the olden days, like a COBOL, Pascal, those were there, but those eras gone. Later on it evolved with high level languages, that is C, C++. Later on Java added. After that there are enormous languages started coming up into the market, like Scala, Python, Go, Node.js, PHP, .NET, C#.NET, Visual C++, and so forth, from open source, as well as certain things are from proprietary. So which language is good for the IT development and for also good pay scale in terms of remunerations? So you need to focus on the cutting edge technologies today, the associated languages. So the predominantly, if you want to work with the system side applications, say like a device drivers and so forth, you can choose either C, C++ platform. If you want to build object-oriented application which is running based on the web hosting and then middleware services, then definitely you can choose Java and associated frameworks or C Sharp, .NET or Visual C++, which is also supporting a graphical user interface applications where you can build. And Go is recently came up, that is also getting good popularity. It is being used to develop certain good products like Kubernetes is one of the major language which used to implement the Kubernetes platform. Python is dominating in the market in terms of the language and web development. There is a framework called Django, and data science. Say you have a data, you can do a data analysis, uh, and on top of that, you wanted to do some kind of a data uh, operations. So that is AI, lot of AI tools also supporting. So Node.js again, it is a server-side framework which has been popular. And scripting frameworks, there are a lot of scripting also coming up. So Python can be used as a scripting language as well as as well as the high-level language where you can develop. Perl is purely used for scripting language and shell scripting, and Node.js also you can write the scripts. Ruby on Rails you can write scripts. Lua, like there are many tools are coming up. Okay, so you have to keep upgrading ourselves to compete in this market. And in terms of if the front end means you have a web application where you wanted to represent your data in a colorful manner. In such cases you need to have a proper GUI, graphical user interface, which is combination of building HTML, JavaScript, Angular, TypeScript, React.js, likewise CSS. There are many tools which combines put together design a proper user interface experience for the customers. So you need to learn, you can learn those, and then you can get good salaries. And in terms of the data operations, so say you want to store some data, you want to retrieve some data, update the operations on the same data, definitely you need the database languages, that is a structured query language or programming language, PL/SQL, and NoSQL engines also it is started coming up. So NoSQL again, it has its own plus and minuses, so you need to focus on that. Along with this, there are cloud native tools they come up with from the AWS, from Azure, from Google. There are many, but they have customized the basic languages into appropriate to fitting into their needs. So these are extensions of the existing high level languages. So please keep updating yourself, focusing on which technology is giving more benefits in terms of the application development as well as a good value to the developers. So now let us understand the software development lifecycle, which we discussed in the second slide. That is, which languages I need to study, how to adapt, all those things we just understood. Now we can understand the software development lifecycle. So SDLC is a process-oriented approach where every application has to follow according to the process. So in my case, I have seen different SDLC models. That was waterfall. That means you have to requirement one phase, analysis another phase, and then development is another phase, and then you move to the development one phase. Likewise, that happens step by step process. Later on, V model came up. V model means at the same time during the development phase, during the development phase, testers also starts writing the test cases at the same time. So when developers ready, so testing team is ready with the test cases, and then they can test it as soon as the use case has been implemented as a V symbol. So in waterfall, it is not like that. It is a one by one step has to finish, then it will go to the next step. Like likewise, and spiral model, that is a kind of a, what I would say, it is a overlapping model with the developers, which can be also utilized and implemented. Now the trend has been changed. It is a purely agile model. Agile means it is very fast. They wanted to deliver the use cases. So initially they come up with Scrum model. So you will have a product expert or product owner, scrum master, then development team, then you prioritize the use cases, and then you build the story points, pick the high priority stories, and go with the scrum model. Later on, scrum has been changed to another model, evolution from the agile XP, extreme programming. That means two people will get two different use cases, but those two people sit together and work as a pair programming. So that is a XP model. And then now the trend is the phase model. So scaled agile framework. This is another model where people are building applications in a 1 week's delivery in the enterprise. So this is another latest trend which is happening from the market. So there are a lot of tools and things to be followed when we are following the software development lifecycle models. So software process all the things, you need to document the things, and then you need to create the stories. All those things has to be utilized as certain tools. Those are the tools being used. Say if user stories are being captured, it can be using Jira, Rally, Azure boards. Those are the set of tools I'm giving you here little bit. You can definitely read out from Google, more and more available. And in case your application completely want to do the documentation, Confluence from the Atlassian products will be used, where you can define your entire application development process, and you can see who can do what, all the diagrams, everything, blah blah blah. In terms of, we are all building with the source code, so maybe you are writing in C or C++, Python, or whatever language you choose to develop in the application. So you need a tool to understand what changes are happening in that particular you know delivery model of your source code side. So you use that will manage a version control system. So I have worked with different tools: svn, c vss, css, perforce, bitbucket, github. Likewise, there are many tools are coming up. So after all the source code has been versioned, there will be certain tools used to deploy our source code into a binary format into the real environment. So those being used as a pipeline tools, Jenkins, Azure DevOps, ADO, likewise, and ServiceNow also being utilized. And during all this phase, there will be a quality assurance phase. So testers also use certain tools to evaluate our application is working as expected or not. They do positive test cases, they do negative test cases, and so forth. So they also use certain tools to develop that. So Windrunner, Load Runner, these are the once popular tools, and now in terms of web-based Selenium, TestNG, and so forth, these kind of tools, JMeter. Likewise, there are many tools being utilized, and say your code can have certain vulnerabilities, because say if you are using a certain already existing libraries which is available freely or with the paid versions, so those libraries can have vulnerabilities. So such kind of vulnerabilities, how we are going to detect it. So such things also to be considered in our application development. So we will use certain tools to evaluate. If it is a Java based application, Sonar Cube and Cynic, these are the tools used for code coverage, how many lines executed, all these things, and is there any vulnerability with the library which I am using it. And in terms of a Python, we use the Pylint, Pylint. So that will give you the code analysis and PyTest for the testing framework. So in addition to this, now cloud native is something, last 15 years it has been evolved. So AW was the pioneer in the cloud computing services. Now Azure from Microsoft, Google from ABC Alphabet, I would say, and also Red Hat started coming with the different suites which is readily available, wherein you can go ahead and use either infrastructure as a service, platform as a service, software as a service. They come up with all these fundamentals. You can choose which platform you wanted to use, and you can deploy your applications, and then you can try to optimize the cost. So these are the primary cloud native vendors today competing each other in the market with huge set of services available in those environments. So as I said, understanding of the hardware, because every application is going to be hosted on a particular machine. So that machine, how it was being designed, that means we are using a computer. A computer uses a hardware, that is a chipset design, whether the hardware supports 32-bit operating system or 64-bit operating system. So based on the operating system bit, it can perform better. That's the reason I was focusing on chipset design. So 32-bit based hardware chips are ready, or 64 bits, so that you can perform the better operations. And then a motherboard. There are different vendors are available: AMD, Intel, Qualcomm, like different sort of vendors available to build the chipset with the motherboards. So CPU cores, nothing but how many thread operations can be performed on the real hardware cores. So that will enable, depends on the cores available in the CPU. And from the CPU means the actual the central processing unit box. And also it will have the associated number of processors. Processors will be basically used to process whatever the instructions has been defined in that particular software. It starts executing. And also hardware can have certain caching by itself. It cannot perform all the operations. Some caching will have from the manufacturer standpoint of view. So based on that, it can support the CPU hardware effectively to operate. And hardware threads also separately they will have it. So how many threads can be used, how many it cannot be used, those are fixed at the motherboard level. And memory, you can have two types of memory: read only and random access memory. These two, random access memory which you can support to based on the hardware type. Say certain server hardware designs which will be capable to adapt 32 GB RAM, 64 GB RAM. People will be keep calling out in the organizations. So how your hardware chipset designed, based on that they will allocate certain slots to install the memory, that is a random access memory. And nowadays the hardwares are keep on growing, multi-core multi-processor. So you have a bigger machines. In the bigger machines you can slice up and then you create virtual machines, so that the overall cost can be reduced rather than procuring separate hardware for each computing machine. And as I said, IT terminology, because in the organization, different people, different ways, they will be calling out certain things. So if it is new to the environment, you will be a little bit confused. So I'm giving my best to help in this particular video how those terminology being used. So all people will be some saying in a different terms. So node, somebody will say, okay, I have a cluster. Cluster has three nodes. You can call either node or compute node. Or somebody will call as a mission. Somebody call as a, in terms of a cloud, they call it as a EC2 if it is a AWS, Elastic Cloud Compute. So they can call it as. That is also one of the mission, and virtual mission people can call. So different terminologies can be used. So be aware of these friendly names, but that represents the same meaning. Okay. And cluster is one or more computers you can place it into one single LAN, or you can have two different LANs, LAN 1 and LAN 2, but you can have a router to exchange the information between these two LANs through a common service. So this is how you can form a cluster. And gateways are primarily basically whenever you go to www.google.com, what happens, you are hitting from your internet on the browser www.google.com. This will go ahead and hit the Google's domain name server, DNS servers, I mean to say, and then that will redirect the request to the Google's gateway, internet gateway. So can I accept this request, and then process that request or not to process the request, and check, do the lot of validations. Any security hack is happening, all those things they will validate at the gateway level, and then they will dispatch the request to their internal cluster, and then that cluster will takes control of the routers, and then routers will be in our home we have the Wi-Fi routers, right? So you get a service provider ISP, and they will install it. They will give you internet connection to the router one port, and then you can use many ports to consume the data from your network, from the land, right? The same way it navigates, and then it goes. And also people have the firewalls can be two types. One is a hardware level firewall, one is a software level firewall. Software level firewalls will be good at some point within the B2B applications. If it is an external facing application, definitely they cannot use the software only. They have to enhance along with the software the hardware firewalls. So there are certain providers, especially they build the products like Cisco systems, they provide a firewall related, hardware firewall related software, and come hardware they keep beneath the gateway to control the endpoints to be protected very carefully. Our IP address are protected by applying certain basic rules according to their networking operations. And in the application development, people also will see the design patterns. So there are different set of design patterns available in terms of the language to language it follows. So people follow, and also people talk about the best practices. Okay, which is the best tool I can choose, which is the best process I can follow, or anything else emerging in the market. Likewise, there are a lot of things are coming up. So please keep updating ourselves so that we can win in this IT era. That's all I wanted to tell you. Uh, Thanks for watching. Please subscribe it, like it, share it. I'll come up with new video. Until then, thanks. Bye.